Bass. Dawaj.
Hi, I'm Gabby, and we're here today to derive a formula for doing a 360 on a snowboard. Today we are going to have multiple people part of this demonstration, but first up will be Rory Keys. He snowboards in Vermont and also in Windham Mountain. We are at Windham Mountain right now. The height of the jump is about 50 inches and the length of the incline is about 10 feet. So with that, we're going to derive an angle using the sine formula and then apply it to the actual spin. But here's a demonstration first.
Wave high, Rory.
That was great. Math. We measured the hypotenuse to be 30.48 meters, and we measured the height of the jump to be 3.048 meters. These values help us find the angle of incline, which we use the sine formula for.
Rolling
Nice.
through the hood to find the boys, kick dust and cuss, crank up some noise. Police on my draws, I have to pause 40
To tell you that the top of the jump is known in mountains as the lip. You take off from the lip.
Man. Motherfucker just following the nigga around, dude. That's real. True shit, y'all. Fuck these failed redneck racist motherfuckers. Man, I don't wanna run no more, but I know that if I stop, I'll be another.
So we timed the rider in his travel to the top of the jump, and based on this information, we can see that he was picking up speed, he was accelerating to reach his maximum height when he would take off the jump. This is necessary for a 360. That was Rory Hughes. So it's important to note that there are components of the velocity, and you have the vertical component, which is the time it takes to reach the max height, and then you have the horizontal component, which doesn't change based on Newton's law that an object in motion will stay in motion until acted upon by an outside force.
Go!
Hi, Craig. Why are you here?
Details and like how to do a perfect one. So we already measured like distance and everything, and I could basically do like the physics for a projectile and just like doing a basic jump, but not with the spin. So my problem is there's something called angular momentum. What's angular momentum? Yikes! Angular momentum is the tendency of a rotating object to keep rotating at the same speed about the same axis of rotation. It is measured with respect to a certain axis of rotation. In case for snowboarders, it would be their nose, or the symmetry of the body. The radius of Eric was 77 centimeters. Eric weighs around 170 pounds, but you also have to account for the board, which weighs about 10 pounds. So, his mass was exactly 81.6326 kilograms. You multiply this by the radius squared and divide by 2 to find the rotational inertia. This will come in much handy later on in the experiment, but now we move to translational velocity.
9-9 style, know what I'm saying? Coming at ya. That's how we do. Yeah.
3, 2, 1. Hi, we're back. We just went over angular inertia, and now we're getting into the translational velocity. Earlier in this project, we found that the horizontal velocity, which was a component of the initial velocity when you're taking flight off the jump. Well, that is equal to the transitional velocity, which is also equal to the radius times omega. Omega is the speed at which you twist. When you watch the video of Eric doing his 360, omega is the speed at which you twist. When you watch the video of Eric doing his 360, you're going to notice that he really throws his body into the turn. That is to increase the omega. Now, we calculated the omega. Now, we're using the horizontal velocity over the radians, which is 8.396 meters per second, over 77 radians, and we're getting omega. Omega turns out to be equal to 1.09. With this value, we're going to calculate the torque and also the rotational acceleration. First comes the rotational acceleration. We're going to use a formula that is very similar to the distance equals velocity initial times time plus 1/2 at squared. Except this time it's going to be theta equals omega times time plus 1/2 rotational acceleration, the variable, times time squared. So, you see the formula to your left. And we're solving for the rotational acceleration, which becomes 17.66 radians per second squared. Now, the torque, which is the force that Eric applied off the ground to complete the turn, is the rotational inertia times the rotational acceleration. This is in newtons, and it's the force applied. Stay tuned to see what this is.
Dun dun dun.
To decide that the things that I tried were in my life just to get high on. When I sit alone, come get a little known, but I need more than myself this time. Step from the road to the sea to the sky, and I do believe that we rely on. When I lay it on, come get to play